This is Velma, fainting goat and cashmere goat crossover. She is mother of 3 and drives her favorite truck, the '56 Ford pickup. This is Steve. He drag races for a living and lives in his mom's basement. And they're off. They're going. Oh, Steve hits Velma! Oh, what is she gonna do? Oh, she's pulling over to the side. Her friends will go over to help her. Oh no, it looks like she's fainted, ladies and gentlemen. Three-legged horse will finish the race. Steve's been doing circles. They're going. Oh, she passes him. Ah, three-legged horse wins. So, how can I take that amazing scenario and turn it into some fancy mathematical things? Well, first, let's make a graph. Now, let's see that exciting race in a table form. So, you see here we have time, Steve distance, Velma's distance, and horse's distance. The distances fluctuate based on where they were in time during the race. It's time to get into the nitty-gritty of the graph and the table. So, what is a function and how do they work, and how is my graph and table a function? Well, a function is simply a mathematical equation that can be put in graph or table form. You can tell if it's a function if, well, you can tell by 2 ways. One of the easiest ways to identify a function is by using the vertical line method. To do that, you simply will look across a line on a graph and think of yourself having a vertical line up on the x-axis or time. And as you would bring that vertical line across the x-axis, you want to see if there's any places where the line on the graph crosses that line twice. So you want to make sure that no one was in 2 places in one time. And if you look at my graph, you'll see that is not the case. So therefore, it is a function. Domain and range are essentially starting and ending points for the numbers that you can put into your function. So the domain is your x values. So the range of x values you can have in a function, and your range is the, well, range of numbers that you can have as your y value. So x is domain, and domain is time. So the domain of this function would be 0 through 15 because my time goes from 0 to 15 seconds. The range would be 0 to 24 because that was the length of the racetrack, or distance, which is my y value. Let's look at the shape of this graph and see why it makes sense. First, let's look at Steve's line, which is the green one. Steve goes at a steady pace upwards with both time and distance. At 5 seconds, he collides with Velma, but continues going straight. Once he sees Velma is pulled over to the side, he does a circle to pass the time. As soon as he sees Three-Legged Horse being in the car and ready to drive, he starts racing towards the finish line. It's a close tie, and he's in front of Velma for almost all of it, or Velma's car. But finally, Three-Legged Horse in Velma's car passes him really close to the finish line at just 14 seconds, and in the last second, Three-Legged Horse prevails and beats him in the race. Now, let's look at Velma's line. Velma, again, goes at a steady pace just like Steve, neck and neck. Once Steve hits Velma, she slowly veers off to the side and stops at the side for about 5 seconds. Then, Three-Legged Horse gets in the car that Velma was driving and drives off. Velma stays on the sideline, so her line stops. Three-Legged Horse, let's look at her blue line, stays on the sideline for a while. Once she sees Velma is in trouble, she races over to help her, and they stand at the car just for a little while. three-legged horse then gets into Velma's car and continues the race for her, beating Steve by just about 0.5 seconds.